let's talk about voltage division and current division rules. As you can see, these two circuits, the voltage division we can do in series circuit, and the current division rule we can use it in parallel circuit. So let's take a look at the voltage division rule first. So in the voltage division circuit is a one loop series circuit, so we can apply KVL using I. So following the direction of the current we assign to the circuit, so it's gonna getting into negative terminal of Vs and positive terminal of V1 and positive terminal of V2, and sum of those voltages equals 0. That's the KVL. Now I can move Vs to the side, then we have Vs equals to V1 plus V2. Now for V1 and V2, we can use Ohm's law. V1 equals to IR1 and V2 equals IR2. V equals IR, right? Now we're gonna use this guy and put it in here. Then we have a Vs equals IR1 plus IR2. And we can factor out I. Now we have R1 plus R2. And from here, we want to just solve for I. Then I equals 1 over R1 plus R2. This whole thing times Vs. So now we're going to use this relationship to find V1 and V2. V1 equals I is what? Denominator is R1 and R2, and we have R1 at the numerator, so R1 V of S. And V2 similar way, the numerator we have R2 over R1 plus R2 times Vs. So this is the voltage division rule. So when we have series circuit, we have a source voltage. Without calculating the current, we should be able to calculate V1 and V2. We'll have some examples later on. Now let's talk about the current division. For the current division rule, we have a source current and we have two parallel resistors. So now we want to call here as a V of S. Then this guy is going to be V of S, and also this guy as a V of S. Why? Because we have a one node and we also have the bottom node, and all of these three components, they are all parallel. They do share top and bottom nodes. So they are parallel. Therefore, voltage across to any parallel nodes are the same. What we're gonna do KCL at node 1. Entering I of S equals to leaving I1 plus I2. And we said V of S equals I1 times R1, V equals IR for the first resistor. And that is also equal to I sub 2 times R sub 2. From this relationship, we can have I sub 1 equals R2 over R1 times I sub 2, and also I sub 2 equals times I sub 1. Now we're going to use this guy and say I of S equals I1 R2 over R1 I sub 2 plus I sub 2. And similar way, we could have I sub S equals I sub 1 plus I sub 2 is what? R1 over R2 times I sub 1. Then we have I sub S equals R2 over R1 plus 1 times I sub 2. And that is R2 plus R1 over R1 if you make a common denominator. Then finally we have I sub 2 equals R1 over R1 plus R2. This whole thing times I of S. Similar way, for the second equation in I of S, we have I of s equals 1 plus R1 over R2 times I1, and we combine those two common denominator as R2, then we have R2 plus R1 and I sub 1. Now we're gonna solve for I sub 1 then. I sub 1 equals R2 over R1 plus R2, everything times I sub s. So this is the current division. So let's take a look at some examples. In the given circuit, you are asked to find V of x, apply voltage division. However, this is not one single loop. We have another loop in here. Therefore, first thing we want to do, we want to combine these two resistors so that we can have a single loop. Then we can apply the voltage division. Now these 6K and 3K resistors, they are in parallel. So if we combine those two, we need to multiply for the numerator and we need to add for the denominator, and that is all equivalent for those two parallel resistors, and that is 2 kilo ohm. Now we're gonna let this guy as Vy and then apply the voltage division. In the voltage division, we said Vy equals itself at the numerator and the denominator, combining those two, 2K plus 3K, and then total voltage supplies to this single loop is going to be 5 volts. Therefore, it is 2 over 5 times 5 volt, that is 2 volts. This Vy is actually Vx, okay? Because that's the parallel component again. Now we can verify this by finding I here. That I is the same as this I, and from here the I equals V equals to IR, therefore I equals to V over R. So I equals 5 volts over R combined 5K, and that means I is 1 milliamp. If you have a 1 milliamp in here, now we can use current division in that 1 milliamp so that we can find this I of x. So I of x equals opposite parallel one, 3K, sum of those two parallel, 3K plus 6K, and then total current applying to here, which is 1 milliamp, and that is 3 over 9 times 1 milliamp, that is 1 over 3 milliamp. If the I of x is 1 over 3 milliamp, then V of x equals I times R. I is 1 over 3 milliamp, and the R is 6 kilo ohm. Kilo and milli is going to go away, and we have a 2 volts, which is same as what we have before. Let's find I of 1. So we cannot use the current division rule at this point because we have more components in here. So we have a 5K and 10K. They are series because the current go through 5K is the same current that goes through 10K. That's the definition of the series as we discussed in class. Therefore, we can combine this as going up current 5M. We have 3K, we have 10K, and we have 15K. Now, this 5M current is going to go through here. So this is 5M. This 5M current is going to distribute it in 10K and 15K, and they are parallel. I of x equals opposite resistance over two parallel, sum of those two parallel resistors times the total current applying to these two parallel resistors, that's the 5. Therefore, we have 15K over 25K. K will go away, and 5, 5, 5, 3 is gonna be 3 amp. Now let's find the V of X. V of X equals I of X times R on there. I of X, we just calculate 3M, and then R is the 10K. So the voltage across here, 30 kilovolts. Now let's verify this to combine this 10K and 15K ohm resistor. Then let's combine them. R equivalent is gonna be they are parallel, so multiply those two parallel resistors in the numerator and then add those two resistors at the denominator. That is 150K times K over 25K. K will go away, and that'll give us 6 kilo ohm. For this circuit, we have a Vx right there. So now we have a 5 amp going through it. So the V of X in a single loop, we have Vx equals to IR, and I is 5, R is 6K, so that is 30 kilovolts. So that's what we have, and they are the same.